Noah.
And I'm Kyle.
And we're here to discuss the mass airflow sensor.
And if you think we chose mass airflow sensors because it has the word mass in it,
and you're goddamn right! We're about to explain
in the douchiest way possible how mass airflow sensors work. The first type of mass airflow sensors used up until 1995 were Vane-type mass airflow sensors. These use potentiometers in order to measure air. These Vane-type mass airflow sensors, they used to use potentiometers of variable resistors. Nowadays, mass airflow sensors may incorporate things like intake air temperatures and fuel cutoff switches.
In order for a mass airflow sensor to operate correctly, it needs three things. One is power. Also needs ground. And it also needs a signal.
Do it, bitch!
Voltage spec for the mass airflow sensor at idle is going to be around 1 volt, as we lifters like to think of it as a single plate. Max voltage at wide open throttle is going to be around 4 volts, or like we like to think of it as 4 plates. Wide open!
When we're talking about frequency of mass airflow sensors, they should read about 2.5 kilohertz at idle and about 10 kilohertz at wide open throttle. Or if you're using a GM vehicle, should max out at about 8.5 kilohertz. We like to think of them as the CrossFitters of the automotive world.
Now this is just a diagram to show you guys visually how this sensor is working. Here we have our sensor, the mass airflow sensor, and we have our ECM here. Then we have the three things that I told you before: ground, signal, and ignition power. When we start the car, this ignition power is going to send current to the resistor, and it's going to heat up that resistor, which is going to make a measurement and send it as a certain voltage for this signal wire so that the ECM can make proper adjustments. But as air cools down the resistor, that ignition power needs to pump more current to heat up and compensate for that cooled air.
Trying to locate the mass airflow sensor is going to be located somewhere between the intake manifold and the air intake box. On this car, it's located right here in between the two. And don't forget, kids, the most important part of locating your sensor is putting fender covers on the car. So right now we're just going over the first steps of doing basic diagnostics on the mass airflow sensor. Your first step is going to be finding the wiring diagram for it, because mass airflow sensors, harness connectors, can have anywhere from 3 to up to 12 connecting pins. So we need to have a wiring diagram to know which of those wires is going to correspond directly to the mass airflow. We need to find our constant power on, our signal wire, and our ground. So the first step is going to be identifying our power that is constant when the car is on. We do this by connecting the test light to ground, finding our pin, and using a forward probe and connecting it and seeing if the test light lights. As you can see, it does, so we have constant power when the car is on right now. Our second step is looking for our ground, so I'm going to connect the test light to power. I'm going to probe to what is, in this diagram, a green and black wire, and then I'm going to run the test light to it and see that it lights. As you can see, it lights, so we have a good ground here. And then just to double check for our signal power, which we should not have the test light light, I'm going to test that. And as you can see, it does not light. So we know we've identified which is our power that is always on when the car is on, and which is our signal power.
So now that we have the picoscope, we can determine if it is an analog or a digital wave. So what we first did is we back probed at the connector for the signal wire. We hooked up our picoscope from the T-pin to the battery negative. Once we start the car, it's going to show a constant idling voltage that's going to the signal wire. And for us, it was around 1.2 volts. It shouldn't drop below 1 typically. Next, we're going to wide open throttle and back off. It's called snap throttling. And that should give us more voltage, and we should be able to see in the waveform on the picoscope if it's going to be analog or digital. Now for this one, it's going to be analog. As you can see, where we started, it starts at about 1.2, and as we snap throttle, it reaches up just below 4. Just pause it and then we can wait. So now we can tell that it is within spec for this mass airflow sensor, as it doesn't drop below 1 and it doesn't go above 4. Now we can tell that this is an analog wave and not a digital, because it's gradually moving upwards and downwards, unlike a digital wave, or also known as a square wave, that looks like that. We don't have a scope and we're using a DMM. We're not going to be able to tell if it's going to be analog or a digital wave. But what we can do is we can tell if there's going to be some variance in the voltage to the signal line. So what we did is we back probed, we plugged in the connector, and we back probed the signal wire, which is, in this case, is going to be the orange wire. Then we hooked up our DMM to the T-pin and to negative at the battery. And then we started the car and saw that this is the voltage to the signal wire that is at an idle. Now what I'm going to do is I'm going to get in the car and I'm going to snap throttle, which means you're just going to get up to wide open throttle, on and off. And you should be able to see that there is a big variance up to about 4 volts in the DMM. So as you can see, Kyle let me know that it was at it went up to 2.5. Now it wasn't wide open throttle, but you could see that it did jump. Now to tell if it's most likely an analog or a digital wave, we don't know for sure. It's not 100% accurate, but what you can do is you can press this button and it turns it into frequency mode. Now because it reads 0, that means that it's most likely an analog wave, because frequency will only be in a digital wave. So now that we have a scan tool, we can show you how to test the mass airflow sensor using the scan tool. I'm using the Solus Pro from Snap-on. What you're going to do is you're going to hook up the OBD2 port. You're going to follow the steps from the scan tools that we now know how to use. And if you look here, you're going to go to Engine. We made sure that we plugged in the K17 key. Then we're going to go down to Data. Engine Data 1. And here you can see the mass airflow sensor in voltage, and you got the mass airflow sensor in grams per second. Now since we started the car, we can see that it's idling about 1.3 volts, about 5.2 grams per second. We should be able to see, if we snap throttle, the change. So that shows how we can check the voltage in the grams per second there. But if we come over here, disconnect the mass airflow sensor port connector, and we probe the signal wire, and we see that since it's disconnected, we have 0 volts and 0 grams per second. But if we load it with the test light and we hook up the test light to power at the source and at the probe, we should see the other extreme. 5 volts, even though we're giving it a full 12 volts, the ECM can only read at a cap of 5 volts. And we see that it's at 287 grams per second. Now what that tells us is that we can tell that since we are getting both extremes, we can tell that the ECM is good. We're getting power, ground, and the component's actually reading, and it's allowing the information that we're giving it when we load it. All the wires connecting to the ECM, to that connection port, all those are good. So that's just one way to assure that we can knock out that side of the circuit. And now we know it's either power, ground, or the actual mass airflow sensor.
You know about mass airflow sensors, how they function, and how to test them. You should have no problem diagnosing faults pertaining to them. And if you have any questions, you can find me and Noah at any gym, at any time, because we're always there maximizing our gains.